All right, this is Chapter 5 review. We have a test tomorrow. Number 1 says, what type of transformation is it shown? What's the translation? Slide. What's a reflection? Flip. What's a rotation? Turn. Dilation. A dilation changes the size. It makes it bigger or it makes it smaller. Could be either one. Okay. The kind that we're studying right now are called isometric transformation. And in isometry, it doesn't change side. So the one of this that doesn't change side is D does change side. So it could be one of the other three. And since it doesn't change its orientation, this answer is A. Translation. Anybody? All right, B, it says, what rule would you use to translate, to slide a figure in the coordinate plane 2 units to the right? Okay, now, which axis is it, which number is it that's changing that goes right and left? Well, the x-axis. The x-axis is the one that goes right and left. Okay, so this is the x-axis. These are horizontal. These are horizontal translations. Back in the back of the test, it uses those terms. It says a horizontal translation. And if you're not careful, you'll get confused right there and go, oh my gosh, I don't know which one it is changing right there. A horizontal translation is the x-axis. Now, as you change that number, you have to add to it or subtract from it. Going to the right is positive, going to the left is negative. Just like if I want to take a point and move it up or down, guys, just like in that equation earlier. In the equation earlier, that I remember what I told you on the one that I put in the T-chart wrong. I said over here, this T-chart, these points should all be 3. As if I have an X value that stays the same and I move something up and down, notice the X isn't changing. As I move up and down, it's actually the Y that would be changing. So my domain in this situation right here, my domain is 3 and my range would be changing. Now what that has to do with this question is you got to know that a horizontal is changing of the X and that a vertical is changing of the Y. And then up and right are positive, down and left are negative. Don't confuse this though. Major mathematical stud statement here. How, again, I've asked this question a bunch of times, how do you write the equation of the y-axis? X equals something. It's x equals 0. Because on the y-axis, does the x change? No, it's the same thing. You go to 0 and then up, 0 and then up. When you do that, you end up with that vertical line, which is the y-axis. The y-axis, which is how you move up and down. Again, up being positive, down being negative. Okay, then I want a horizontal move to the right and left. So the one of these that would move 2 units to the right would be F. Anybody? All right, is a transformation a reflection?
Yes.
Yeah. Okay, this is a reflection. It looks kind of, I kind of, at first glance, thought it might have been a turn. I thought it might have been a rotation. But if you look at it, okay, yeah. So it's a reflection around that. Am I good? Is this transformation a translation? Yes. Yeah, it is. just slid right there. If you slide everything right there, that's a translation. See, it says, what is the image of 5,4 when it is rotated 180 degrees about the origin? Remember, this is the one that we talked about, guys, 90 and 180. These really are the only two that I need to give you. If we know that a 90-degree rotation takes the y value and makes it x, and the x value, and it stays the same, but becomes the y, and a 180-degree rotation just puts it on the other side, guys, that gives us all the other ones. And remember from yesterday, the standard way to turn is counterclockwise. If I don't say +6, if I just say 6, you assume positive. If I just say a 90-degree rotation, you assume that it's counterclockwise. I have to tell you the other thing. So once I do this, it's just a matter of taking these points right here and changing them to -5, -4. So the image would be -5, -4. Remember, the image is where it ends up at, and the pre-image is where it starts. Anybody want to explain why I'm saying here that I don't need to give you 270? How is it that you should know what 270 is? That's right. It's just the opposite of 90. So the opposite of 90 would be, okay, if I took that and made it the opposite of that, that would be y and -x. Now, what happened to us yesterday on the quiz, problem number 4, guys, look at problem number 4 real quick in just a second when I finish this. Clockwise. Make sure you identify that said clockwise. Before y'all turn those in, as I'll give you an opportunity to fix those first 6, and we'll talk about them, but make sure you understand that says clockwise. Guys, 90 degrees clockwise is not what we've talked about up here. 90 degrees clockwise is 270 degrees counterclockwise. Why 90 and 270? So what's 90 and 270 add up to be? 360. So there's the whole circle. Okay, so all right, that's 5. 6, LM is reflected across the x-axis. Remember, when something's reflected across the x-axis, x stays the same and y changes. So if I'm going to reflect this across the x-axis, m, the x value of m is going to stay the same. So if it says it's reflected, then translated right 4 and up 1. Ooh, wow, that's pretty cool. So the first thing it is LM is reflected here. Here's M, here's L. Then it says, then translated right 4 and up 1 in which quadrant? So if I went right 4, 1, 2, 3, 4, and up 1, here's my final image. There's my final image right there. And what quadrant is that? 4. Because here's first, here's second, here's third, and here's fourth. Again, this is what I talked to y'all about, guys, but there's information that you have talked about before you got in here, and it's knowing what the quadrants are. This is a little key as to why I always used to wonder why do we count that direction? The reason we count that direction, that's the counterclockwise. Okay, so this is where they're both positive. That's where they're both positive, so that's the starting point. And then we went counterclockwise. So the answer to this one would be J. 7, the composition of 2 reflections. Think about that for a second. Composition of two reflections across parallel lines. A, translation. So I reflected. I reflected. It's not a rotation, because if it was a rotation, this thing would be turned down. It ends up being one way, then back to the original direction. So its orientation would not have changed. That's a reflection. Last. All right, that'll get me through 1 through 7 right there, so that I have time to go over the rest of the stuff. What I'll basically do is I'll do 7 questions. I'll do 7 questions in every class.